A large standard deviation says there was a wide range of scores when you're talking about standard deviation and how much people agree. Now let's take a look at an example. We have an example here of some standard deviations. We have 2.5, 3.4, 1.9, and 4.8. Now, which of the above standard deviations has the tightest cluster of scores about the mean? Well, if you look at these, the largest one is 4.8, smallest one is 1.9, so which has the tightest cluster of scores about the mean? That is 1.9. It's the smallest number, meaning that there is the least disagreement. Now, which has a bowl-shaped normal curve? That would be 4.8. It's bigger, and that would be a larger normal curve, or a normal curve is the same thing as a bell curve. Now, on an opinion question, if everybody agrees on the answer, the standard deviation will be small. It'll be a small standard deviation, and this is a great tool to have when you're looking at some questions. Say you have a bunch of questions in SurveyMonkey, and you want to see which ones they agreed on and which ones they don't. Well, SurveyMonkey actually is a tool that will give you standard deviations, small standard deviations on each of them as far as bell curves, and it will show that. And you can look at the ones that have skinny bell curves and know right away that those people agreed. Maybe they were being asked a question about Biden or Bernie, if it was the Democratic question, and probably shouldn't get into politics. Some people are still, upset with Bernie's deciding not to run any longer. But if you asked that question and it had a small standard deviation, you would know that everyone agreed. You wouldn't know until you looked at what they said, what they agreed on, but it would tell you that they agreed on it. You might ask a question like, how much do you like the coronavirus? And so you have 1 to 5, with 5 being the most. And if the standard deviation was 0, you would know that everybody agreed on it. Now, you wouldn't know whether they agreed on number 5 that they love it, or number 1 that they don't love it. But my guess, if I were to guess that, if there was a possible way to make money off of that, I would guess that it would be that they don't like the coronavirus. It would have a small standard deviation. If there is disagreement on the question, the standard deviation is large. So if you want to know about a couple of topics, which ones are controversial, look for a large standard deviation. Look for a wide, big bell curve. And that is visually just going to stand out, and you can do that. It's a very practical, this is mathematical statistics, but it's a very practical way to do that. And most statistical packages or survey packages will have those options that you can just look at a standard deviation on each of the questions. So comparing standard deviations reveals what questions show disagreement. Very helpful tool. Now we're going to look at the shape of the bell curve. And we were talking about that can tell us things just by looking at it. If it's standard deviation, whether there was agreement or not agreement. That shape of the bell curve is called kurtosis. And you can see I have a picture of a canyon here with the kind of different shapes, and kind of a well-known canyon that a lot of people hike in and get pictures at. But the shape of the bell curve is called kurtosis. Now there's different shapes, and so we have different names for those different shapes. And so we can communicate just by talking about those shapes. A tall, narrow curve is called, nothing that you've heard before, leptokurtic. So if you had a curve like this rock formation, that would be a tall, narrow curve. If it was standard deviation, it would be that everyone agreed on an item. So leptokurtic shows a lot of agreement. Leptokurtic, some people say that the curve is leaping into the air, lepto, and That is one way that people remember it, a mnemonic. Now here would be another curve, more of a bowl-shaped curve. And a bowl-shaped curve is called mesocurtic. Now, one way I remember it is that this picture here is a mesa, and you have mesocurtic. So if you think of it, it looks like a mesa. Then in out west they have these. Then you know it's mesocurtic. I think this is this mesa is like similar to, I think it's Devil's Tower, where people climb quite a bit. Now a flat curve is called platykurtic, not to be confused with Katie Couric, who was a news anchor. But this is platykurtic. And now, see, I told that joke and I didn't hear any laughter, and so I feel right at home in like my class is right here. So platykurtic is what a flat curve is called. Now, I think of it as a plateau. Plateau is flat, and so a flat curve is platykurtic. Other people say, think of it as a platypus, and I don't think of a platypus as flat, so I don't think that's as good, but maybe a platypus that is like being very flat on the ground, that might be a mnemonic to help you remember this. So a guide is mesocurtic curve, leptokurtic is leaping, and platykurtic is, you know, you could also maybe say platykurtic is like a plate. It's kind of flat. I just was thinking of that right now. It's a stroke of genius. Okay. We're getting to the end here, folks. We really are. I know this is some brutal stuff, but we're going to talk just a couple more things. We're going to talk about sample distribution. Sample distribution is the distribution of some characteristic measured on the individuals that were part of the sample. So if you have a characteristic that is that everybody in the sample has, then that would be the sample distribution. For instance, if you had a group of people and you want to do, maybe it's the COM 400 class, we want to find out what the distribution, the sample distribution is of people who are really good at playing basketball, maybe people who can throw free throw shots. Not necessarily people who are good at basketball, because Shaq was just not good at free throws, and I say that because he is not here. But maybe we were going to do that so everybody gives free throws, and there's a bell curve, and it comes to me, and people are saying, Dr. Banning, use this. Obviously, he's a really good free throw athlete, and I am not. I would be on the lower end of the bell curve. But that would be sample distribution. It's how a characteristic is distributed in the sample. Now, ideally, the sample distribution should mirror the population sample. You should, that's why you take a sample, and if you find that, maybe we take a sample of people to see what kinds of food people have been eating, and we talk to 500 people, and people say, my COVID-19 diet is I'm eating more fresh vegetables, or maybe it's I'm eating snack food and ice cream. I don't know what it would be. I think I'm a little bit of both of those. And but hopefully, if you take a sample, it will be the same as the population, so that you can say, I talked to these 500 people, and I think I can project this is what people are thinking. So this means that the sample represents the population. It's the reason we do experiments. Getting ready to close up, we're going to look now at the population distribution. It's the same as the sample distribution, except it's on the population. So you're looking at how people are spread out in, or how that characteristic is spread out in the population as opposed to your sample. Now, usually you don't know how it's spread out in the population. However, if you're looking at something that is measured by the United States Census, which we'll be taking this year, then you can actually compare. And so when I do studies, I usually like to check to say, do I have the same age makeup as the actual people in this city, which I did when I was in Baton Rouge. So population distribution, the same as a sample distribution, except it is on the population. We're going to stop there. I know I have given you a lot this week on experiments, but this is some important stuff. I'm guessing you may see a lot of this again on the final exam. So it was worth it. I will see you next week.